Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the other equations of state for real gases. The first one is the virial equation of state. In 1901, Onions proposed the equation of state expressed in the form of power series, the virial equation. The word virial stems from the Latin word for force. In the present usage, it is force interactions among molecules that are intended. Where A, B, C, D are the first, the second, the third, the fourth virial coefficients. When the specific volume tends to be infinity, we have the compressibility factor tends to be unity. This means the gas tends to be ideal gas and A equals 1. The coefficients B, C, D are all functions of temperature. The virial equation can also be expressed as a power series of pressure. The relation between the coefficients is: the second one is the Beatty-Bridgman equation of state. The Beatty-Bridgman equation proposed in 1928 is an equation of state based on 5 experimentally determined constants. It is expressed as: the constants appearing in this equation are given in Table 4.2 for various substances. The Beatty-Bridgman equation is known to be reasonably accurate for densities up to about this value, where ρCr is the density of the substance at the critical point. The third one is the RK equation of state. 3 other two-constant equations of state that have been widely used are the Berthelot, Dietrich, and Redlich-Kwong equations. The RK equation, considered by many to be the best of the two constant equations of state, is: this equation, proposed in 1949, is mainly empirical in nature, with no rigorous justification in terms of molecular arguments. The RK equation is explicit in pressure, but not in specific volume or temperature. Like the van der Waals equation, the RK equation is cubic in specific volume. Although the RK equation is somewhat more difficult to manipulate mathematically than the van der Waals equation, it is more accurate, particularly at higher pressures. The fourth one is the BWR equation of state. Benedict, Webb, and Rubin extended the Beatty-Bridgman equation in 1940 by raising the number of constants to 8. It is expressed as: this equation can handle substances and densities up to about this value. The values of the constants appearing in this equation are given in the following table. Complex equations represent the PVT behavior of substances reasonably well and are very suitable for digital computer applications. For hand calculations, however, it is suggested that the reader use the property tables or the simpler equations of state for convenience. This is particularly true for specific volume calculations, since all the earlier equations are implicit in V and require a trial and error approach. The accuracy of the van der Waals, the Beatty-Bridgman, and the BWR equations of state for nitrogen is illustrated in the figure. It is apparent from this figure that the BWR equation of state is usually the most accurate. Okay, that's all for this task. Thank you very much, and see you next time.